Okay, class, today we're going to start some geometry from chapter 10. We're going to look at 10.1, points, lines, planes, and angles. Okay, and also I'm going to throw your Easter egg in here. The Easter egg for this video is 735187. That's 735187. We're going to first start with some terminologies, just to get us acquainted so we can get into this. So first we're going to talk about what a point is, obviously is a point. We're not going to address that. We have several different ways of looking at lines. First of all, if I draw like a straight line like that, and I put a point on each end, this is called a line segment, because it has a beginning and an end. Okay? If I now draw something that has an arrow goes on and on and on to the right and stops on the left, we call that a ray. And then a line is when I go infinitely in both directions. Okay, that's a line. So those are just some terminologies, okay? Now we can talk about an angle. Let's talk about an angle. So those are all the ways we think about lines. So as an angle, let me just get to something here in a minute. In my notes, I was going to use this. So at an angle, if I have an angle here, an angle is comprised of two rays. Okay, the angle has its vertex. Okay, this is the vertex of the angle. Okay, this is the actual angle itself is in here. This is the angle itself. And that's measured for this class in degrees. When you get onto trig, if you ever take that, it's measured in radians also. This is called the initial side of the angle, this bottom ray. And this is called the terminal side. It's where the angle stops. Okay. So every angle has an initial side and a terminal side and a vertex. The way we'd write that, notation-wise, is we could say, the book uses this notation like this. We could call this thing angle, we put a little symbol there through it, angle 1, let's say, or angle A sometimes, or B. If I put points on it, let's erase all this and do an example. Sometimes what will happen is they'll draw an angle like that, okay, and they'll put some points on this. Point, put one on the vertex in here, and they'll label those as like D, E, and F. So we could call this, sometimes it'll be called angle E. Sometimes we could also call it angle DEF. Basically you follow around. DEF is this angle, okay? That's another way to write it. We could also, I forgot to put the little angle symbol, we could also write it as angle FED, okay? Or sometimes they'll even throw something in here and put like a 3 in there. Or we could also call it angle 3. So those are just different ways that it can be represented, and they all mean the same thing. So in different contexts, we use different ways of looking at it. Okay, so now let's talk about the units of an angle. The units of an angle for the purposes of this class is 1 degree. So a degree is equal to 1/360th of a complete rotation. Here's what that means. That if I take some side and I take that side, imagine it's on a little pivot here at its vertex. And if I take that thing and I rotate it all the way around and land back on itself, then that side swept out a 360 degree arc. So 1 degree is 1/360th of that sweeping out, so to speak, if that makes some sense. Okay? So there's 360 degrees in a complete circle. So that means that, let's take a look here, that if I imagine like your XY plane here, if I start here with my terminal side here, okay, or my initial side here, and I sweep out up to here, okay, this angle is 90 degrees. Because it's 1/4 of the way around a 360. Because, you know, I would go 1, 2, 3, 4 equal swept out distances. Okay? And then when I come around to here, okay, if I come around to here, that whole angle would then be 180. And then I could keep going around to here, and then that whole angle around would be 270. You getting the idea? And then if I went all the way around, if I circled all the way around like this, as we've already talked about, that one would be 360. Okay, and there's all kinds of angles in between as well. Okay, so right now we're just getting acquainted with terminology. So on a clock, if I think about a clock, let's say the minute hand moves from the 12 to the 5. What angle was swept out? By the hand. Okay, let's draw that for a minute. If I draw a clock, okay, the 12's about here. It is not exactly there. This is 12. And 5 is somewhere about right there, right? That's the 5. Okay, so first we need to look at it. This whole thing is divided up into 12, so that means that, you know, there's 1, 2, 3, 4. So what is swept out? The question mark is, what is swept out by each number? Okay, what is swept out by each number? Well, there's 12 of them. We know that all the way around is 360. So that means that it should be 360 divided by 12 would give me my question mark, right? Because there's 12 different numbers. Well, what's 360 divided by 12? Well, that is 30 degrees, right? So that means that this is 30 degrees. So that means that each one of these numbers is 30. So if I just count them up, I've got 1, 2, 3, 4, 5 times 30. So that would be 30 times 5 is 150 degrees. Should be the angle swept out. If I went from 12 to 8, it'd be 30 times 8, and so on and so forth. Okay? So that's a way to think about angles in clock lingo. All right, so let's talk about a little bit more terminology here. We got two different things. Two angles are complementary when their sum is 90 degrees. Okay, so for example, if I take a 90-degree angle, this is a 90-degree angle right here, and I divide it into 2, and I call this one angle 1, and this one angle 2, then angle 1 and angle 2 are complementary, because you can tell by the picture that they add to get the 90 degree, okay, angle there. Okay, two angles are supplementary. So this was the, sorry, underline that, are supplementary when their sum is 180 degrees. Okay, so I'm out of room here. So going on to the next page, that means if I draw a straight line and put my vertex here, that's 180 degrees, meaning if I go around to here, that's 180. Okay, and I draw a line here, and I called this one angle 1, and I called this one angle 2, then angle 1 and angle 2 are supplementary in this case. Okay, so again, we're just really building up some terminologies, okay? So now let's work on some problems, and I think we're gonna, this stuff is not gonna be super challenging for you. Okay, let's find a couple angles in here. Let's find the angle, first of all. Whoops, somehow I picked gray. Let's find the angle CAE. Okay, well CAE, if I traced it, starts at C. CAE, that looks like a 90-degree angle in the protractor, right? This protractor gives the angle measures, assuming that my terminal starts at AC, right here. So that looks like that would be 90 degrees. Okay, let's try angle BAF. Alright, well BAF is right here. Starts at B, goes to A, goes to F. Well, this is not too bad. It's just, it goes from, it starts at 20 degrees on the protractor and it goes to 130 degrees. That would make that 110 degrees if I subtract 130 minus 20, right? So that's 110 degrees. Let's go to angle GAE. So GAE is right here, GAE. Well, that looks like it starts at 90 and goes to 160. So this would be 160 minus 90, which is 70 degrees. Okay, that's an example of how you might read a protractor. Okay, let's try this problem. Pretty simple. I'm getting all these problems from the book, by the way. I want to find the angle question mark right here. Question mark. Okay, so what I do is, you can tell by the picture that this entire angle right here is what? It's 90 degrees, isn't it? So that means that 32 plus question mark, since they both are adding up, they have to equal 90. So if I just subtract 32 from both sides, I find my question mark. I get question mark equals, what's that come out to? 58 degrees. That's my answer. Pretty easy stuff here. Okay, this one's a little bit tougher because it's a word problem. The measure of the angle is 81 more than twice that of its supplement. Okay, so supplement should cue you into the idea right here that we're talking about two angles whose sum is 180 degrees. So here's what I'm going to do. I'm going to draw a straight line with a vertex. There's my vertex. And I've got two angles that I'm looking at. The measure of one angle is 81 more than twice that of its supplement. So let's just draw a line here, and we got two angles. This angle, okay, and then we got this angle right here, blue and black. All right, so the measure of an angle is 81 more than twice its supplement. So we got two unknowns here. Let's call the smaller angle x. My bad. And then in blue, let's do the larger angle. It says 81 more than, so that'd be 81 plus, that's more than, twice is 2 times that of its supplement. Supplement is the other angle that is adding to it to get 180. So these two angles in this picture have to add to get 180. So we know that this angle now, 81 plus 2x plus x, have to add up to get 180 because they are supplements. So this is 81 plus 3x equals 180. So 3x equals 99. So x equals 33. So now we know this angle. This is 33 degrees. I'm not done, because we want to find the measure of the angle is 81 more than twice that of its supplement. We're actually trying to find this angle, the other angle. So to do that, I do, in blue, 81 plus 2x. So I know what x is, plus 2 times 33. This is going to be 81 plus 66. And I get 147. There's my answer. So this angle is 147. Okay. So the key is you got to use these cues here, guys. More than means plus. Okay. Twice means 2 times. 2 times. Okay. So that's a good problem. There's going to be some problems like that in the homework. Okay. Now we're going to talk about some properties. Some angle, what we call alternate interior, alternate exterior angles. So in general, we've got some theorems here. Theorems are big ideas that are always true and are proven in math. Is if I got two lines intersecting each other, doesn't matter how they're intersecting, what angles they're intersecting, the angles opposite each other are always equal. So this angle will always equal that one, and this angle will always equal the one across from it with two lines intersecting. Okay? We have another situation where if I had two parallel lines, so this is situation 1, let's go situation 2. If I have two parallel lines, so parallel means that two lines have the same slant, or another way you could think about it is they never intersect. These two lines are parallel. If I draw a line that cuts those two lines like that, there's a lot of angles in here that are the same. So I'm going to do in orange, I'll do all the angles that are the same. These two angles are the same because they're just like this example over here where they're across from each other with two crossed lines, okay? These two angles are the same as those other two above. So all the orange angles are all the same angle, okay? And then in purple, these four angles are all the same. Okay, that's going to help us to figure out some of these problems, okay, that we're going to get here in a minute. This is a review of geometry. Most of you guys should have had this in theory in high school. Okay, let's try some of these problems on the basis of that picture. So let's find some different things here. So let's find in number 26, we'll start with that. So for 26, let's find angle 2. Okay, well, isn't angle 2 just straight opposite 133? So wouldn't that just be 133? Okay, now let's find angle 3. We'll notice that angle 3 plus 133 both add up to make this whole line, don't they? Okay, so that means that angle 3 is really going to be 180 minus 133, since angle 3 and 133 add up to get 180. Okay, so that's going to be 57 degrees. Okay, let's go on to this next one. Let's find angle 1. Well, notice that angle 1 and this 30 degree add to get this 90 degree angle, don't they? They're complementary angles. So wouldn't that mean that angle 1 is 90 minus 30, which is 60 degrees? Okay. Angle 2. Well, it looks like angle 2 is just this whole angle, which is a right angle, isn't it? So that's a 90 degree angle. That one's pretty easy. How would I get angle 3? That's an interesting one. Well, there's a couple ways we could think about it. The easiest way to think about it is to kind of look at this and go angle 3 plus this 90 degree angle right there plus this 30 degree angle all add up to a line which is 180 degrees, isn't it? So a note here, angle 3 plus 90 degrees plus 30 degrees equals 180. So that means that angle 3, if I subtract the 90 and the 30 over, should be 180 minus 90 minus 30. That's 180 minus 120, which is 60. So you're always looking for things that add up to 90s and 180s in a lot of these pictures, or things that are across from each other. Okay, let's try another one. This is one of the examples with the parallel lines. This line and this line are parallel. Okay, we use the up and down, two straight up and down lines to mean parallel. Okay, so now we're going to find some of these angles. Let's find angle 4. Well, if you notice in the picture, if you remember from what I just showed you a minute ago, angle 2 and angle 4 are the same. Or, sorry, angle 2 and angle 4 are not the same. But I can find angle 1, and I was screwing up. Angle 1 and angle 4 are the same. You can kind of tell by just looking at them, can't you? They're the same angle, since those two lines are parallel. So let's find angle 1. Well, we know that doing some more side work here, angle 1 is just 180 minus 54, because angle 1 and this 54 add up to get that line, which is 180. So if angle 1 is 180 minus 54, that would make it 26 degrees. So that's the same as angle 4. And now I know everything I need to know in the picture, because angle 1, 4, 3, and 7 all have the same measure. So this is the same as angle 1, 3, and 7 as well. And then angles 2, 5, this one, and that one are all the same. So all the rest of those angles, angle 2, 5, 6, are all equal to 54 degrees. Okay. Let's find angle 1, 2, and 3 in this one. So let's start with what we can find for sure. So we have to do some problem solving here. First of all, I want you to notice I'm going to put in purple that these two lines are parallel. That's important to notice. That's going to give us some help. Okay, I'm going to leave those written there in purple. Okay, so first of all, I can find this angle, couldn't I? Because like I can't directly get angle 2 right here with what I know. But what I can do is I know that if I find this angle in blue, it'll be the same as this angle right there, right? Because the two parallel lines. So that angle in blue, the blue angle, is going to equal 180 minus 63 degrees. Do you see that? Because the blue angle, this angle, and that one add up to this line, which gives me 180. So that is 17 degrees. 117 degrees, my bad. So now I know in orange here that this angle plus that angle add up to 117. So I know that angle 2 plus 60 degrees add up to that angle, blue angle, 117, because they are the parallel line situation. So that means that angle 2 is equal to 117 minus 60. Okay, and that's 57 degrees. Okay, so I have angle 2. Okay, to get angle 1, I know that from the picture, if I take a look here in purple, if I all three of those angles, 1, 2, and 60, add up to 180, they form that line. So I can write that. Angle 1, I keep forgetting to do that. Angle 1 plus angle 2 plus 60 degrees is equal to 180. Well, I know angle 2 now, so angle 1 plus 57 degrees plus 60 degrees equals 180 degrees. So angle 1, I just subtract, take 180, and I subtract off the 60 and the 57 to the other side, and I get 63 degrees. So that's angle 1. And then how do I get angle 3? Well, angle 3 is kind of tricky because angle 3, if I go in orange, angle 3 is the same as that angle, isn't it? Because of the parallel line situation. So angle 3, I'm going to erase a little bit up here, keeping in mind that this is angle 2. So angle 3 is going to just be angle 1 plus angle 2 in the picture. You can see right here, angle 1 plus angle 2 is the same as this angle because these two lines are parallel. So that's going to be 63 degrees plus 57 degrees. So these are kind of a puzzle. I get 120 degrees for that one. Okay, that should get you ready for the homework.